Okay, so let's move on. So I'm setting the context for this discussion. So an echo. So where we are and what is the purpose of the discussion? So as you all know, in the coming years, you will see an increasing number of SAR missions, Copernicus missions, non-SAR Copernicus missions, InSAR capable missions, and even third-party and commercial missions, and which offer great possibility for doing new science and new applications. And we as a community and as a space agency, so we have to prepare for this so that we can the best support the scientific work. And the purpose for this session is to get recommendations to ESA in particular. And the situation is that for individual Sentinels or Copernicus high priority candidate missions, the science plans and preparatory activities are well defined for each mission in isolation. There are mechanisms in place to get the scientific recommendations into the MRD mission science plans. There are mission advisory groups that talk about these missions. But there has not been enough preparatory work for consult scientific communities on what we can do with all of these missions in a synergetic manner. So the purpose of this discussion today is to get recommendations. How do we prepare for the future? And just very quickly, these are the Copernicus high priority candidate missions. So these are missions that are to be launched after 2025 towards the end of the decade. So if we look down the list, the last one is known by all in this community: ROSEL, L-band radar. There's then optical missions, altimeter, radiometer, atmospheric gases mission, and hyperspectral imaging. So there's a wide possibilities of doing science between all of these missions. Then I should also add to this list that, of course, we have the ESA Earth Explorers also to keep in mind, and we have Biomass and Harmony in the pipeline. Harmony is still in the candidate stage, but it's as we've seen in the discussions today, it would really be a great asset to this community. And then I have just a couple of very high-level seed questions here. So I would like to have an open discussion on just what kind of ideas, the community has. So this first slide is about a wider range of missions, and the second slide, I will show it. My last slide briefly is a similar slide about InSAR missions. But let's start with the HBCMs. So these questions like, so what are the practical challenges that we have to tackle if we want to exploit multiple SAR and other missions together? Which are the applications and science cases that where we most likely will see the largest impact? So are there any low-hanging fruits that we should address first? At which product levels should we explore the synergy? Is it sensor geometry or maybe in some higher level products or ARDs? Data access, of course, is an issue since many of these missions have significant data volumes. And then the question is, so this is really the point of discussion today. So what can ESA do in order to prepare for all of these new missions so that the communities will be ready when the missions are flying? So you can propose studies, campaigns, software tools, theoretical studies, test beds, platforms, workshops, and training activities. So anything is on the table. Okay, so how to best tackle this? I guess that we should start with 1A, and who would like to make a comment? So, sorry. Before, can you share the slides so I can see the chat? So Fabio, do you want to comment as you already started?
No, really, my comment was really the idea of exhuming the concept of staggering the bursts of Sentinel-1A and B, actually, even before the other mission, just with the mission we have now, because everybody now is complaining about bias and they are understanding it. So maybe to stagger the burst would be really a good idea. And so anyway, it would be worth thinking.
Yes. Yeah. We should save that discussion for the second part. Sorry, I had to reshare my presentation here. So the question is, so what are the main practical challenges we're dealing with joint use of missions, taking into their account the different characteristics?
Marcus.
Yes, hello.
I wonder why this question comes up now, because we have these challenges, or have had these challenges all the time now, because all of the points you were raising, they are already here for the current Copernicus missions. So the different geometry, etc. So I would say that the challenges remain the same. Maybe the solutions, we have better solutions in the future.
Yes, so the idea of discussion is that how do we best prepare as a community, and how we as a space agency can support this thing. So we have still some years to go to 2027, 28. So how to proceed?
And one point is I wasn't able to attend most of the Fringe conference, unfortunately, but maybe it has been mentioned already. But one particular point in SAR is that it is the only imaging method from space that can achieve an extremely high geometric accuracy, a geodetic geometric accuracy in the range of centimeters. And I think this should be a requirement for the future SAR missions. It has not been a requirement for Sentinel-1, you know. We are just about to correct for this with additional correction information layer. But I think this is something very unique that we have in SAR. So the SAR mission should be able to give a geodetic reference for all of the other data. Also can be used for geocoding of optical data. So this must be guaranteed, I would say, that precautions have to be made that the SAR data have an absolute geolocation accuracy out of the box of, let's say, 10 centimeters or 2 centimeters or something in this range. This is the first thing. And this is also important when it comes to a point that you addressed on your slides, analysis-ready data. So if we are using data jointly from different sensor technologies, then not only the experts in remote sensing will use the data, experts from other fields use the data, so they want analysis-ready data. This is clear. So we need also a type of data level where all the geolocation, etc., has been done already, and people from computer science can directly, and also small companies can directly dive into the data and do their evaluation. But geometric accuracy is one of the key issues, I think.
Very good points, Richard. Thank you. Are there any other comments?
Marcus,
Yes.
Francesco here.
Hello.
If you just thinking about geometric accuracy, I'm always concerned about L-band and geolocation. So this 10 centimeter are very hard out of the box. So I think we have to use the data and yeah, and see what we can do. I think it's challenging. That's clear.
But it should be a requirement, Francesco, shouldn't it? So we should keep it in mind from the beginning to aim at the maximum possible.
Yes. Yes, I was saying this like a couple of days ago in for the atmosphere session. We are seeing these wonderful things with X-band and C-band, but they are difficult to replicate because they are like just based on GNSS models and everything. And I think it's difficult to replicate in L-band. I think in L-band we have to use data. And if we have to do this, then this might have implications for the instrument, might have implication for the processing. It could be a bit more challenging. Otherwise, we try to meter or several meters in azimuth. I don't know, like difficult.
But as far as I understand, it is L-band sensor flies in kind of tandem with Sentinel-1 next generation, I think. So they can be used synergetically, probably also for correction of these admittedly very high geometric errors in L-band if you're considering ionosphere.
Probably they're flying days apart, or
this is too long. Yeah, but there's something to consider. I mean, if we can find a solution for this problem, this geolocation problem in L-band and the ionosphere problem, which is also an interferometric problem in a way, a almost simultaneously acquired C-band data could be helpful. Something to be investigated.
So, what kind of actions would you recommend that we take to make sure that this dual frequency operation with high geometric accuracy will be possible? There's something that we can do now with the existing spaceborne systems, or do we need campaigns or?
We can look at how do we get absolute phase with L-band. I think it's difficult. We have tried and we are not really there, somehow close, but not really completely there. So I think if this is really a need because I'm talking from a signal processing point of view, and so if there's a real need there, then one can look better into this and see why we are not there. And we were using like 3 bands, using not the normal spectrum, but using 3 bands and trying to get some absolute ionosphere. I don't know, but it's difficult because it goes into all the difficult, how to say, systematic errors in the instrument or whatever. You become very sensitive. It's very noisy. It's like a second derivative. It's very noisy. Or other ideas which I don't have yet, but maybe there are other ideas. I don't know.
Sorry, Richard, when you say when you said 10 centimeters out of the box, so you mean without co-registration? So if we don't reach 10 centimeters, then we'll have to co-register and fix it after.
Marcus, yeah. So I agree with Francesco. I was still in the Sentinel-1 domain, and I was also thinking about Sentinel-1 next generation, where I think this can be definitely be implemented. But I agree with L-band, it will be extremely difficult. But nevertheless, I mean, we have some time now, and everything should be done to investigate on how accurate we can become with L-band, because everything at the end boils down on how automatically the data can be exploited later. So what we don't want is that the users have to co-register data. I think this is very difficult for them, or we have to do it for them to arrive at analysis-ready data, which will be the standard, definitely. So in a couple of years, there are not enough experts in who know exactly about SARs. They simply want to do something with the data. So we have to look into how accurate the geometry of this data can be, whether it's 10 centimeters or whether it's a meter. We'll see, and whether the mission scenario can help us. I have no concrete proposal.
No, I think this ARD, I tend to agree with you. Some people, of course, with a technical workshop like FRINGE, they say that it's impossible to find an ARD that pleases everybody. But I think that in this case, for the less InSAR and SAR savvy users, we have to find a solution that is going to make most people happy outside of the technical community. Maybe, Thibaut, could you put this next slide on, because we've been talking about SAR, so this is pretty much the same questions. So regarding product levels, so we would want to have, I presume, level 1 products from Centre-1 and ROSEL and Centre-1 next generation on the same grid, and then also an ARD possibility later. There's a comment from Philip Durand saying get ROSEL very close to S1. So this is certainly still a possibility. It's recently discussion has moved to the putting them 3 days apart, but there's still many years to go. So this might change. So it depends on the requirements from the users and the of the services as well.
So here's Thomas. So maybe regarding this question 2B, so which applications can be for the use for multi-sensor measurements? And I think a combination of Sentinel-1 and ROSEL close to each other and also at the same grid, so that we can match. So to have interferometric products available at L and C band would be very attractive for many ice applications, like ice velocity, for example, but also grounding line. L band, we know, so both would have 2 satellites in orbit, so 6 days apart. And if we are going with this almost simultaneous acquisitions of ROSEL and Sentinel-1, then of course we can use both frequencies. On one hand, the longer frequency L-band to bridge incoherent places in C-band. We can even go downwards the faster glaciers to extend the interferometric velocity products in regions where C-band already decorrelates. And so a combination of both would be really attractive for these applications. Also for grounding lines, that would be very nice to have. And already preparations could be done when we are looking for combinations of Sentinel-1, for example, with SAOCOM A and B. So we would have 8 days and 6 days interferograms. So if they are matching, that could be already to plan the scenarios for a combination of the 2 Copernicus SAR missions.
Right, so you're also recommending a campaign of acquisitions with both sensors in land ice studies.
Hi, Marcus. That's Javier here. So under my opinion, the closer we can have ROSEL from Sentinel-1 C-band data, the better, especially in case of land classification and land use. So when we are facing ground field data that are changing very fast in time, so whatever it's fast motions tracking or vegetation, different status, growing, etc. The closest we can have this data, so the closer the gap we can have, ideally the same day would be perfect. The more we can exploit together C and L, different properties we can see from the ground, especially if we look at sigma naught or if we look at at coherence. So, you know, with C-band already, we saw that the interferometric coherence, short 16 days coherence, improved a lot the classification. So we imagine we can have these in different wavelengths, but sampling at the same day. So we will have indeed we can improve the accuracy indeed with this approach. So this is my point of view.
Okay. Are there any campaign data sets airborne that would be useful in doing these studies? I guess over ice, probably not. Sure if over agriculture there are. Because in the end, the case we would need to make is that CNL few minutes apart is way better than the CNL 3 days apart.
Another application what would be very useful to combine backscatter changes of Sentinel-1 and Roselle InSAR for 3 retrieval. So we use the C-band in this case for discriminating dry snow and wet snow. And for the dry snow areas, we can apply the interferometric approach to retrieve snow water equivalent, which will not work out for wet snow, of course. Would have a bias, but this would be also a requirement to have C and L band acquired close together under the same or similar imaging geometry.
Yeah, I imagine that for sea ices the situation
it will be
is
the
same.
same. Yeah, so sea ice applications also request to have a dual frequency acquisition almost at the same time.
Any other comments? So, because really, if we think about the candidate missions and combining SAR data with non-SAR data, what kind of opportunities would that give scientists to? That's something that, like I said in the opening slides, it is something that kind of falls in between MRDs, mission requirement documents, so it's not well captured currently, and we are taking a coordinated effort together with the European Commission to ask scientific communities in all of our workshops this is the same question. So how do we prepare? How can we help you? So any other comments are welcome. Okay, right, I see it, yes. So it's about question 2A from Pablo Gonzalez. As discussed in the earthquake science and volcano science, to advance our science, there is desire in those communities for shorter revisit time, 1 day, to capture dynamic and hazardous processes or develop near real-time responses to crisis. Solutions have been suggested, e.g. using the upcoming Sentinel-1C, although it seems not possible at the moment. Can other missions address this requirement? Does somebody want to tackle that? I think that personally, I also think that adding a 1-day tandem configuration for Sentinel-1C would be fantastic for many of the science communities. So hopefully this before it's time to fly Sentinel-1C, that there is increased funding available for the operations. But this is of course is a high-level political decision, not something we can do much else about than express our wishes.
Yeah, so here's again, Thomas. So we discussed this in the ICE session, and there was a recommendation, which I will present later on today, to really go for a ERS tandem-like constellation to have 1, 5, and 6 days repeat intervals between A, B, and C satellites. This would be really, for ice application, a kind of game changer, because the jump from, or the increase of coherence over glaciers and ice from 6 days to a 1 day interval is significant, while what we know a little bit from other campaigns like ERS 3 days, the change between 6 days and 4 days, what is another option for the constellation, is much less, has much less impact on coherence, and will not have, the main impact will be a kind of temporal coverage, of course. But from the application point of view, the attractiveness of the products which can be generated is much higher if we go for this type of constellation. So we completely support this. And I think there was a strong vote also from the science community, from Ice and Snow, to go for a kind of scenario like this.
Thank you, Thomas. If there are no further comments right now, I read Tim Wright's question from the chat. So we should make sure we have the ability to measure a long track motion accurately with good, about 1 millimeter a year accuracy with ROSE-L/Sentinel-1 and or add-on missions like Harmony. We should think about the missions together as a system to achieve 3D motion measurements. So what should we be doing in that? I mean, with Harmony, this is clear. As far as I know, ROSE-L and Sentinel-1 NG will both have ScanSAR and not TOPS. So if you were wishing to benefit from the squinting of the beam, that will not be available. But we'll have to think of other solutions. Tim, do you want to make a comment?
Can you hear me?
Yep.
Yeah, I guess I don't know what the solution is, but I think when we're in a world when we'll have Harmony for 5 years, and that will be fantastic, we need to be thinking about what follows on from Harmony in terms of moving from that kind of research mission into a operational mission, because I think those 3D motions, we can get them out of the TOPS mode, but presumably we could do other things with other modes potentially, or split band processing. If you've got a high enough bandwidth, you can do some things with multiple aperture interferometry, or maybe you need to squint some of the satellites so they're not looking in exactly the same direction. They're not looking at zero Doppler. I don't know. There's a number of ways you could do it, or maybe it has to be done with add-on missions like Harmony follow-on. But we should be thinking about it now as a requirement for all of the satellites to try and work out a solution so that we can get those along track, so we can get the 3D motions is essentially what we need for lots of applications.
Sure. So since you mentioned Harmony, do you have some recommendations to what do we need to do to prepare in the next 5 years? Is there something that
I think they've got a very strong mission advisory group that seems to be making some sensible suggestions. I think Harmony looks like a great mission, so I'm not sure I have any specific recommendations, but it's more about thinking about the follow-on, and then how we, in the 2030s, I guess we're talking about now, but that's when these we need to start planning now, because if we've already made decisions on the configuration for Sentinel-1 next generation, ruling out certain configurations, then we need to think of what else we need.
So perhaps after Harmony there comes Super Harmony.
Yes. Harmonics satellite. Anyway, yeah.
But yeah, the discussion is a bit wider than what takes place in the mag, in the sense that we also need to get the community ready for Harmony so that we hit the ground running. So do you have any, what kind of things are missing there? Do you think there's anything that we can do to make communities ready?
I think there's the usual things. I think getting us prepared for what the data is going to look like, and the more analysis ready the data can be, the better, I think, so that we can just use them out of the box. That would be helpful.
So you recommend that one of the standard products is an ARD, and we will find a way of defining that in a manner that is most agreeable to most people.
Yes, and I think it's similar. We've come up with a similar recommendation in Tectonics for having pre-co-registered SLCs, even for Sentinel-1, the current generation. I think that would, those kind of things that make it easier for many users to use the data without all of us doing the same number crunching to come up with the same same shifts in the data, for example.
But you don't want them in terrain corrected, because then the person next to you might say that that's a great idea, Tim, but we would also like to have them terrain corrected. And we can't do all, because at least if we are distributing the data via pickup points, the volumes just come unmanageable.
Yeah, but I think the terrain correction, I think the problem with that is that terrain changes, doesn't it? So whereas the gross co-registration parameters don't change. So I think that gross co-registration is something InSAR could do, as long as we know, and I think Ramon made this point in one of the earlier days, as long as we can undo anything that is done. So as long as we know what's been done to a data set so that it can be undone. But if 99% of users are co-registering the data, I mean, maybe this is something you could do a survey on. I don't know.
Yeah, I don't know anyone who does not co-register in the InSAR.
Right. Yeah. I mean, I think with the improvement in metadata, I think you don't necessarily need to do the co-registration but I think most of us are still doing it. But
so if we get the richest 10 centimeters out of the box, so is that enough?
You should ask some other people, I think. I'm talking too much.
Yes, more comments from the audience. Thank you, Tim. Ricardo has raised his hand. Sabrina.
Yeah, the video is not starting, but I think it's okay. I know it's fine. Concerning this 3D motion analysis with L-band, probably one possibility would be with ROSE-L, as it is a SCANSA system, as you mentioned, is to accept to lose a little bit of signal to noise ratio and thinking about moving from a single look SCANSA system to at least a 2-look SCANSA system. Essentially, this way you would have an angular diversity like you have in Sentinel-1 in the regions of the overlapping bars, but in this case extended to the entire footprint. So this is one possibility that probably we should think about it, if it is acceptable, or if we have a little bit more signal that we can squeeze from the amplifier. And the second thing that is in the same direction, I don't know if you're aware, but there is a starting discussion about bistatic opportunity. It's called ROSE-L Plus, if I remember correctly, that could be used in different scenario. One of the possible scenario would be having a significant different squint angle, thus providing information about the tree motion. Probably you should think a little bit about this opportunity, because this would give to the future L-band this 3D capability that it's very important, as we heard.
Grazie, Riccardo.
You are welcome, Marcus.
Okay, so there's a question or answer to 2C or comment. Rachel Holly. There's been lots of discussion on tension between ARD ease of use versus retaining lower levels for flexibility. There seems to be a consensus on co-registration, but for any ARDs beyond that, it's important to be clear on the capabilities and limitations of the chosen parameters. Help users decide which ARDs are right for their applications and what they can or cannot use them for. I haven't personally followed the CEOS ARD process very closely, but how do they manage these issues here? Because it must be the same kind of issues must pop up all the time in the discussions. Okay, there's another question or comment from Giovanni Cuozzo. It would be nice to have a new free SAR-DM dataset after SRTM, eventually coupled with optical data to fill the gaps. There is actually a new SAR-DM dataset available. It's called the Copernicus DEM, and at least the 60-meter version, I believe also the 30-meter version are free for everybody. So Giovanni, you might want to check that. And if you want to say something, just raise your hand. Ricardo, your hand is up. Is it still up or you raise it again? Ah, okay. Yeah, so thinking about applications. So how about hazards? InSAR is used widely in the hazards community. So is there something that we should do to get ready for combination with high resolution optical sensors or thermal sensing missions or other missions would provide complementary data for working with hazards? And are there any recommendations? Okay. Any other comments? They can also be quite technical and detailed. So what there is, we still have 15 minutes to go. I have a couple questions from Klaus Schippal related to the biomass mission. So there's question one is, does the community have any specific needs in terms of data products and formats? So data products and formats for biomass. Any recommendations there? Anyone? Okay, so no specific needs in data products and formats. Then the second question regarding biomass mission is coverage. We will cover Antarctica and non-forested areas on a best effort basis. Any requests for hotspot areas where we should observe in specific modes, for example, InSAR, TOMOSAR, both ascending and descending, covered only once or every 9 months? So basically, test site suggestions. Thomas, for land ice, I mean, we know that it's Antarctica will be a challenging area for biomass because of the ionosphere, but in case that InSAR works well there.
Yeah, so I just think about a proper test area. So there are a couple of places which would be of interest. Of course, for the development and validation, we have to check that also sufficient ground-based data are available so that we can see which signatures and which layering we are observing. So we had a very successful campaign, airborne campaign in an alpine glacier together with Polymi, and this is really a very good test case. And I think but biomass will not acquire, of course, over the Alps, as far as I know. And so we have to go to these dry snow regions on Antarctica. But I have to look actually where validation data are available. So we have some experience in this, and we have to sit together and check for the proper test area.
Would you have an idea about sea ice?
So I'm not a sea ice person, I have to say, but so probably we have to point this back to the MAC group or to people in the auditorium who can comment on that.
Okay, thank you, Thomas. I'm sorry. Yes. So yeah, we still have some time. So you don't have to use all of the time, but there's still one of the last chance in this workshop to discuss things in a technical session. So we could use time to our benefit as well. We will prepare, gather the recommendations and the result of discussion, and we will compile it with the feedback that we get in from our other workshops as well. So we are doing this, like I said, in all of our EO workshops from now on. Are there any more questions in the chat? I don't see anything there. Okay, so if there are no further questions, I was wondering, Sabrina, is it possible that we try to take a group photo? Is it possible to get the attendees visible as well? Or is this impossible in this setup?
Don't see the attendees. The attendees is impossible, but if the panelists can switch off their camera, I can take a screenshot to tweet then at the final session.
But what if we make everyone a panelist and then ask people to switch on their camera? Just we have 10 minutes. I mean, in the real physical Fringe, we always take,
if it works, yes, there's 84 participants. I don't think WebEx is having so much powerful for 84 videos on, but we can try. Yes, I can make everybody as attendee. I do. Okay.
64 attendees. Okay, and then there's a grid view. Oh, see as many people as possible. Okay. I thought that WebEx meetings has 10,000 participants max, but yeah, they don't fit on one screen. All right. So quite a few people here. So all right, so who's going to take the screenshot? Get ready to smile.
Muikku in Finnish. Cheese.
Yes.
Muikku. Okay, so I try to, should I go for a snapshot? Let me see. Yeah. Where is the snipper? Snipping. Okay, I snip you all.
Fantastic grid view. I probably as much as I could.
Okay.
One sec. Hold your
One
horses.
with waving.
I need to make another copy. Okay. 1 sec only. Bear with me another second. Snip. Only one moment of patience. Okay.
We need a countdown.
Yeah. New. Okay, now we're smile. Okay.
Got it?
Yeah, more or less. Not everybody, unfortunately.
Okay, so I guess we can close this technical discussion. So we are getting closer to the end of this workshop. So next in the program is
There's a break, and then we should do the conclusion summaries and obviously the closing session.
okay. So have a nice coffee break and see you again in the summary session at 3:30 European time.